So good morning, everybody. Today is Tuesday, February 23rd, and today we're actually going to do a quick warm-up review. If you need to pause the video, maybe take a look at these 5 warm-up questions related to inequalities and the concept of domain and range. Please do so. For the first question, what we're going to do is, just to make sure it's okay, we're going to try to solve and graph this inequality. I'll read the question to you. The question is negative 2 times x plus 6, which is greater than 4x minus 5 over 2. So one more time, inequalities seem strange for a lot of students. Treat them like equations. So imagine that's an equal sign. So you're going to use your SAMDEV, or a lot of you might know as reverse BEDMAS, to solve this. I think some of you know what you would do. Maybe some people on the left-hand side would actually expand this. So we get negative 2x minus 12, which is greater than 4x minus 5 over 2. Notice divided by 2 is a problem here. And that's what we're going to manipulate. We're going to multiply both sides by 2. If I multiply the right side by 2, I have to multiply the left side by 2. But when you multiply this by a nice number, meaning a positive number, nothing happens to the inequality. So what's going to happen for the next line? I think everyone agrees we're going to get negative 4x minus 24, which is greater than 4x minus 5. Notice what it looks like? Just like in grade 9. A binomial equaling another binomial. So what should we do? I think everyone's okay. I'm going to subtract 4x to both sides. I'm going to go this slowly. Because that's going to get rid of this 4x. So maybe put all the x's on one side. What am I going to get? I'm going to get negative 8x minus 24 is greater than negative 5. What am I going to do next? I think I'll add 24 to both sides. And I get negative 8x is greater than, what's 24 minus 5? Is that 19? I think that's 19. Here's the kicker. Hard part of this question. In order to get rid of this negative 8, let's use a different color just to make sure I'm all right. The negative 8 is going to divide both sides by negative 8. So 19 is a prime number, so we get x, and this is going to be negative 19/8. And watch what happens to the inequality sign. The inequality sign changes. Let me just double check that I did this right. Negative 2, blah, 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 negative 12. I think it looks good. Can someone from the class double check that I did this right? Thanks, Adam. And now I have to graph this thing. What is this number? Well, this number on a number line, we'll do the answer above here if that's okay. I think that's, what is that? 8 goes into 19 twice, so negative 2 and something. So this negative 19/8 is probably here, right? And then what am I going to draw? I'm going to draw an open circle and go towards the left. Because it's less than. Why open circle? Because we're going to use, or it's because it's not the same equal. Any questions about that from the class? This question is clearly pretty hard. So you're not going to get something like this on the test, but there's a lot of elements here that's enforcing what we kind of reviewed online and from the handout. Any questions about inequalities or any questions from the handout from the class? Tom?
So the idea with the greater than sign is pretty much just treat it as an equal sign.
That is correct. In this case, actually, it's a greater than sign. Treat it like an equal sign. The only exception is when you're solving, when you multiply or divide by negative, and if you look at your handout, it says it right there. When you multiply and divide by a negative, the inequality sign changes. And that's what we discovered, right? We did that proof there. Or we did it on the YouTube video. And yeah, exactly what Tom said, right? Treat it like an equal sign. Okay. Anyone else? Question A. Notice now let's talk about domain and range. We have a set notation here. And notice we're just going to talk about domain and range. Again, domain and range is really, really weird. It's like a weird math concept. It's more for communication. There's not real much math in it, although there's a little bit, but the notation is kind of weird for some students when they see it. So the answer for the first question, and again, hopefully that's okay, I'm just going to do all these answers, but feel free to interrupt me and ask the questions. The domain for this question and the range for this, we use capital D and capital R. And I think with this set notation, a lot of you know what we're gonna do. X is equal to 3, -2, and 1, and technically we go in order, so you won't get penalized if you don't do it this way, but we tend to go from the more negative to the more positive. And this is the most important aspect. I'm pausing here for a second for effect. However, if you really want to get good notation, you put a vertical line. This vertical line means such as. That's what that means in mathematics, such as. Such as. X, EI. And again, one more time, this E, this epsilon, is actually stands for belongs to. So in English, this is what it would translate. The domain for set M is when X is equal to -2, 1, and 3, such as X belongs to the integer number set. But it's so much easier to write this as this notation. The range, any volunteer want to try to give me the range for this one? Really easy, no pressure. Karen? 7? 7 is correct. And again, you just have to be specific. Notice range is related to y, so y is equal to 7. And again, this is the most important part, y equals 7, such as y belongs to integers, right? One more time, notice if I gave you the domain and or range for some information, notice we can't go the reverse. Although in this case, it's probably obvious because there's only 1 to 7 here. Now, if you decide to use natural numbers or whole numbers, that's fine. Adam.
So it doesn't matter what you, like it belongs to, you could belong to whole numbers? Or
You could put the whole numbers for this one. Now, for this one, there's a negative, so
yeah.
it's technically integers there, right? And don't get me wrong, we just don't know. I would not, that's why, in substance, ladies and gentlemen, in grade 11, no offense, it's, this is not super important. Okay, it's not super important, the I or the numbering set. It's just a formality, just to put a disclaimer. Like, so for example, I'm gonna date myself. If you talk about a video game, let's say Street Fighter, this is a fighting video game. Some people would argue, but Mr. Which Street Fighter you're talking? Street Fighter 2, Street Fighter Alpha, Dark Soccer, Street Fighter, Marvel versus Capcom. Anyways, there's so many different types, so we gotta be specific in this orientation here. Now, question B, C, and D, they're a little different from your handout. And the reason why is because, obviously, when I teach this, I kind of lead it because I don't have any graph here, right? So be warned, it's a little suspicious. Hopefully you did your homework. These are obviously example 2 from the handout. So I'll do the first one for this one. Notice it seems to start somewhere over here, and it seems to get more towards the right. Again, notice I don't know how it gets like that, so hopefully if you're drawing it right now in class or at home, and you're copying the notes, we don't really care what the rule is right now. However, in terms of the domain, notice it starts at -5, and it keeps on going towards more positive. So watch what I'm going to do, and again, hopefully this will make more sense. X is greater than or equal to -5. Again, notice this is the more important part. Let's dissect why I wrote this. I wrote equals because this is a filled-in dot. Everyone see that? It's a filled-in dot. And notice which way it's going? It's going more and more positive, or more and more larger. So that's why it's greater than or equal to. And finally, notice where it's telling me where it started from. It started from -5, and it goes on infinitely. So notice you can just write x belongs to real numbers. Now some students argue, why can't I put integer or whole number? If it was integer or whole number or anything like that, then it would be discrete. And this is clearly a continuous line. Right? So it keeps on going. In short, some of you realize what I'm going to do. Some students actually use this technique. And notice what I did. The domain is conceptually related to the x values, right? So it goes towards the right. So some students, even though this is the function, it is a function because it satisfies the vertical line, but this is the image. Notice this is just a number line. Let's see that? Can someone try maybe give me the range for this? What's the range for this? Claire, want to try?
Y is greater than or equal to -4.
Nicely done. And again, how she's doing it, maybe for some of you, you're realizing, notice the y-axis, it's just another number line. So it starts at -4, it's not gonna go more negative. I see it going more and more positive. It should start in a negative region. But this image seems like it's going up, up, and up. And that's what you're seeing. You're basically seeing a number line, just like this. But notice from this question, I can't go back to the original question. I can't. It's just telling me its boundaries or its distribution. And again, just for formality's sake, y belongs to real numbers. Because then again, let's pause here. I like this example rather than the examples that you've seen in example 2. But any questions about this? And this is probably what you'll see. So one more time, there's a couple of questions on your test on Monday. You're going to kind of see that. For those people that are watching this at home from class 3A, your test is obviously this Friday. So question C, notice it looks like a semicircle, right? It looks like a semicircle, but it's not an enclosed shape. And let's just see if everyone can do that. Hopefully, again, if you're at home and you're zooming in at this, I'm basically telling you from obviously the x-axis and y-axis what you're supposed to do. So somebody new perhaps, you're from this class? Oops. Any volunteer want to try to give me the domain and range? And again, this math is weird. It's like, Mr. Chen, am I calculating anything? You're not really calculating, you're just looking and describing. It's almost like using words. Where are you seeing the image? Right? And this is like maybe, that's why a lot of you, when you may watch a movie or you watch cartoons, if it's not immersive, like if the CGI is not immersive, then you see the distortions, right? And this is what we're doing. Okay? This is what we're doing. Adam, you want to try the further domain?
X is greater than -6, but x is not greater than 5.
Or x is less than 5, right?
X is less than 5.
Nicely done. So one more time, ladies and gentlemen at home, this is a nice understanding, and this is why I have to do this particular question. Notice how Adam said it, and I'll say it again, repeat it. X is greater than -6, but less than 5, right? And again, visually, watch what I'm doing, ladies and gentlemen. Let's go above, that's okay. I see something like this. It's greater than -6, but less than 5. Here's how we actually write though what Adam says, and this is actually important, okay? So the way that we actually write this, and hopefully this is on the camera. Oops. This is how we rate it. Even though it looks weird, -6 is less than x, which is less than 5. What Adam said, ladies and gentlemen, again, people at home, x is greater than -6, but x is less than 5. Why do we write it this way? It's a valid question. In grade 12, we have to eventually teach you what's called interval notation, or if you decide to take advanced functions. And the way that the interval would look, this is what it would look like. I know it looks like an ordered pair, but that's how you write it. And notice what's first, the more negative, and then the more positive. Okay, so this is why. It actually matters the order. Okay, unfortunately, you can't just be willy-nilly. So don't get me wrong, unfortunately you will get penalized. And don't get me wrong, I think some of you say, but Mr. Chen, why can't I write it like this? X is less than -6, comma, x is less than 5. Why can't I, greater than -6, why can't I write it like this? It's just, in mathematics terms, this is bad syntax. It's bad communication. Even though conceptually, this makes more sense what Adam said. Everyone okay? So the different volunteer try to give us the range? Hi, want to try?
-2 is less than y, and y is less than 3.
Less than or?
3.
Okay, so really, really close. So I try to, and again, I apologize, it's very subjective here. It's supposed to go to the 3, because that marking there. So I do apologize, ladies and gentlemen. So it would be a valid question, ladies and gentlemen, if you were to ask me, right? I'm trying to say this actually touches at 3, so there should be a dot there, but I didn't want to lead it too much. So I wanted to see what you would have said. So in terms of what you're seeing, and again, I'll do it vertically. So notice what I'm doing. It seems to go all the way to there, between -2 and 3. At least you got the boundaries correct. Everyone agree? It's between -2 and 3. That's how you describe it to somebody. But x is, y is greater than -2, or less than or equal to 3. It seems to touch like this. And again, the red and the green, they're just there to help you to see it as on a number line, right? That's why some students actually like putting it on top. It's just, for me, it looks a little messy for teaching purposes. Okay, these are obviously a little bit harder than the question that you saw in example 2, but I think they're a little bit more provocative, more kind of engaging in what you might see. Everyone okay with that stuff? And hopefully you can see my numbers here. So let's just see if someone actually can try question D. And again, thank you so much to the students. Don't feel bad if you got it wrong or whatever. Let's try to consolidate some information here. Preferably two different people. Any volunteer for question D? Want to give us the domain? Want to give us the range? And this one actually seems a little bit easier because hey, they look like horizontal line segments. This one's going to seem weird, and I'm challenging to see if you could, open your horizons of the concepts that we have actually been teaching. Okay. Any volunteer for the domain? And don't get me wrong, try to say it to me in English, that's fine too. Anybody? Again, I appreciate Adam and Ty, they helped us out a lot. Maybe somebody new in the class? I don't know, maybe Karen or Eden or Abby or Rita or Lucy, Angelique or Andrew, Tom? There's help us out actually. Yeah? Anybody? Who cares? If you get it wrong, who cares? Who
How
cares?
would you say that though? As in like, are you looking at the?
We'll talk about the domain. What do you see?
Well, I wouldn't really know how to say it though. If I were to like explain it, I guess. When you go like, X is something like, equal to -5 or greater than, like how would you say it?
Okay, so we're having difficulty here. So in English, I would say, Mr. Chen, I think it starts at -5. So I like going from left to right. When I read a novel, when I read a book, I tend to read from left to right. There's some mangas, if you read manga, they go top down and they go right left, right? Because it's Japanese. But I tend to read from left to right. So if I were to talk about this in English for the domain, notice I'm going from left to right. I go, it starts at -5. Hey, wait a second. Doesn't seem to include 2, but then they seem to keep on going forever. So let's just break this up into its parts. This line segment is from -5 to 2, sort of, up to 2, doesn't include it. And then from 2 onward, it doesn't include it, then goes 2 onwards. How am I gonna write that? So I'll do this one, I think. So, -5 is less than or equal to x, which is less than 2, and that's this part. Everyone see that what I'm pointing at? And then this part I have a semicolon, x is greater than 2. Notice this is what's called a discontinuity, right? If you were to draw this literally, some of you didn't see me draw this. I drew it, and I literally have to lift up my pen, or my chalk, and then keep on going. So this is like, there's a hole here. And I'm emphasizing it because it's non-including 2. So what that really means, if I were to continue this line segment, for the first part of this trip, let's just say, it goes to 1.9999999. It doesn't go to 2. Lift up my pen, and I really wish I could start at 2 again to keep on going. But it's 2.00001. Notice that's greater than 2, and it keeps on going. I think that you guys understand what I'm doing when I say those numbers. The range is pretty easy. Any volunteer? There. 1, 3. And the reason why, because they're horizontal lines. And I got it. So it's just something to showcase something about what we're looking at. And hopefully everybody got that in the video.